This video is going to show you how to create a position time graph based on this velocity time graph. The first step we're going to do is divide up our graph into the different sections every time our lines change shape. So we've got a box, we have a triangle box combo, we've got another box, we've got another triangle box combo, we've got triangle, and a box. All right. Your next step is going to be to find the areas of each of those sections. So for your first one, it's 1 times 6, so your area is going to be 6. Next one, you're going to find the triangle and box separately and then add them together. So your box has an area of 1. Your triangle is a height of 5 and a width of 1, so it's going to be 2.5. So total is going to be 3.5 for that. These 3 boxes down here are all the same size, so we can go ahead and put a 1 there. But this little triangle it also has an area of 1 because its height is 2, its width is 1. So 1/2 times 2 times 1. So total there is going to be 2. This triangle has a height of 3 times 1, so it's going to be 1.5. This triangle is the same size, but it's below your x-axis, so its area is -1.5. And then this box has an area of -3. Alright, so I'm going to circle the areas we're going to work with. There is a decimal in there. So those are the areas we're working with. So our next step is going to be create the graph. So your area is how much you're going to go up or down on your graph. If it's positive, you're going up. Negative, you're going down. So for the first section, we are going up 6. So at 1 second, I'm going to be at a height of 6 or 6 meters away. I have a horizontal line for that section. So on a position graph, that means I'm going to have a diagonal line. The next time I'm going up 3.5, I'm going to go up 3.5 more. So that's going to be 9.5 at 2 seconds because that's where that time interval ends. I have a diagonal line there, so that's going to mean I have a curve. That diagonal line is going towards 0, so that means I'm slowing down. So my curve needs to imply that I'm slowing down. For the from 2 to 3 seconds, I'm going up 1, so I'm going to be at 10.5. And that is going to have, again, another diagonal line. From 3 to 4 seconds, I go up a height of 2, so I'm going to be at 12.5. And then in that case, I'm speeding up, so my curve is going to imply that I'm speeding up. Then I'm going to go up 1.5 more, so I'm going to be at 14. And in this case, I'm slowing down again because my diagonal line is approaching the x-axis, so that's slowing down. Now when I have these negative areas, that's when my lines are going to start going down. So this little red triangle is -5, so I'm going to go back down 1.5 more, so I'm back at 12.5. And it is speeding up because my diagonal line is going away from the x-axis. Then I'm at 12.5. So I'm going to go down 3 more. So what is that? 9.5 I'm going to be back at. And in this case, I'm going to be have a diagonal line since I have a horizontal line on my position graph. So you've got your areas here. Match how far you go up and down. If it's positive, you go up. When it's negative, you go down. Your shapes of your line here tell you if you're keeping constant velocity, so you need constant velocity on here. If it's going towards your x-axis, like these two are, you're going to be slowing down. If you're going away from your x-axis, like here or here, you're going to be speeding up. So you're going to have curves that are speeding up.